In this video, we will be using Cranium to demonstrate the utility of static curves. We will be using Cranium version 3.2, core version 315. We will analyze the vapor pressures of alkyl derivatives of levulinic acid, specifically the methyl, ethyl, and propyl derivatives. Our goal is to compare the vapor pressures of these various derivatives by generating a vapor pressure versus temperature graph showing the vapor pressures of all derivatives. We begin by starting Cranium. Once Cranium is started, we open the MKS template knowledge base. A template knowledge base contains estimation techniques, groups, elements, and references, but it contains no chemicals and no mixtures. We save a copy of the template knowledge base by selecting the Save a Copy command from the File menu. We enter a name for the new knowledge base, open the new knowledge base, and close our original template knowledge base. And then change the title of our new knowledge base. We then change to the Chemicals chapter and add a new page for our first derivative, methyl levulinate. Enter the chemical's name and some comments. Scroll down to the chemical structure section, click the left mouse button, and enter the structure of our first derivative. Enter carbon atoms, oxygen atoms, bond the atoms with single bonds, and double bonds. Finally, change one of the carbons to oxygen. Press Save. Now that Cranium knows the chemical's molecular structure, it can generate physical property estimates. From the Commands menu, select the Compute Estimates command. Cranium will estimate more than 30 different physical properties. Properties such as critical temperature, critical pressure, thermodynamic properties, phase transition enthalpies. Scroll to the temperature dependent section and select the liquid vapor pressure estimates property. Click on the data table and enter a series of temperatures. Series starting at 0 degrees C and going to 250 degrees C. Again, select the Compute Estimates command from the Commands menu, and Cranium will generate a vapor pressure estimate for each of our entered temperatures. The two different color symbols indicate that Cranium selected two different estimation techniques. Specifically, for the low temperature estimates, Cranium used the Gomez-Nido-Thodos equation, and for the high temperature estimates, Cranium used the Ambrose-Walton method. To compare these vapor pressure estimates with those for the other derivatives, scroll up to our table of estimates, click right, and select the Copy Variables and Estimates command. Scroll down to the graph, click right, and select the Edit Static Curves command. Paste our copied values into the table, and assign a curve to each estimate. The graph now shows our estimated values and also our entered static curve value. Scroll up to our chemical structure section, click the right mouse button, and select the Copy Structure command. Now add a new page for our next derivative. Enter the value ethyl levulinate. Enter a reference and comments. Paste our copied structure into the structure field and click the left mouse button to edit the structure. Add one more carbon to change our methyl derivative to an ethyl derivative. Bond the atoms together, click Save, and once again scroll down to the temperature dependent section, enter a series of temperatures, again from 0 degrees C, 250 C, and compute all estimates. We see that new estimates for ethyl levulinate are shown in addition to the curve for methyl levulinate. Scroll back to our estimates table, copy these values, scroll to our graph, and paste these new estimates into the same table as our previous estimates. But give these new estimates a curve named ethyl. Once again, scroll up to our chemical structure section, copy the structure, and now repeat the same process for our propyl derivative. We now have generated estimates for each of the three alkyl derivatives. As we page forward and backward through our knowledge base, ethyl, methyl, we can see how the vapor pressure changes as we change the molecular structure. Just for fun, we can repeat the process one more time. Copy our structure, add a new page, in this case, isopropyl levulinate. Add a new carbon and remove the end carbon. Scroll to the temperature dependent section, enter our series of temperatures, and generate estimates. Interestingly, we can see that our isopropyl derivative has a vapor pressure somewhere in between that of the methyl and normal propyl derivative. The goal of this demonstration was to show how to use static curves, and hopefully to show you how they can be very useful, especially when you are comparing physical properties. Looking at how physical properties change between molecules, especially between structurally similar molecules, can often give you a great deal of insight into the chemical's behavior. Thank you very much.